All right, so I believe yesterday we completely finished the free response question. Is that right? We had our first kind of encounter of a like part A, part B, part C, part D problem. Okay, we're going to go ahead and move on to page 45. Again, we're looking at this connection between algebraic work and a graphical picture or representation. But we're going to focus a lot on just the graph today. Like, how can we read a graph? How can we answer particular questions about a graph? So the entire first page is relating or pertaining to the graph at the top. We're going to answer a bunch of different questions about this one picture. Okay, so if you take a look at the top left-hand corner, it says, remember that if h of 3 equals 2, what does that function notation mean? Can we identify what the x value is and what the y value is based off the way that's written? Go ahead, Ashlyn.
X equals 3 and y equals 2.
X equals 3 and y is 2. So if you know an x value and if you know a y value, you should then automatically know the ordered pair point that should be on the graph. Okay, so we're going to focus on that notation and therefore the connection to the graph. We're going to focus on that today. Okay, so on this graph to the right, notice how we have two different graphs. One's a dotted line, one's a solid line. And in this little, in this little paragraph here, they're telling us that f is the dashed line. So it might be in our best interest to perhaps label that. We'll say f is the dashed line, and g of x is the solid line. Okay, so we have to keep that idea in the back of our heads as we go through some of these different questions, because it can get difficult. You have two graphs on one picture. We got to figure out, are they asking us about the f graph or are they asking us about the g graph? Okay, keep your thoughts organized. So our first question here is f of -1. So based off of what Ashlyn told us at the beginning, this -1 is representing an x value. If you were to plug in -1 in for the x on the f graph, what would the y value be that you would get out? Can we find that point on the graph? Go ahead, Marie. It would be 5. Okay, so f is the dashed or dotted line. If you were to plug in -1, notice how you would get out. Did you say 5, Marie? Yes. I know the numbers are very faint. We might have to count 1, 2, 3, 4. I think it's 6 though. Is that okay? We might have to count. I know the numbers are blurry or tiny. Okay, you may have to count. Okay, so we're not necessarily using an equation in this case. Okay, if we did have an equation, we know if we would plug in -1, our answer would be 6. But since we don't have that equation, we're just strictly using the graph to figure out these pieces of information. Okay, go ahead and try f of -9 and f of 5. Remember, we're dealing with the dotted graph. They're asking us about f. Any takers on f of -9? What do you think, Marie? 10? Okay, so if we go to -9, it looks like the f graph is at 10. Do we have a point there, though? There's an open circle, right? Okay, so no point. If it was closed, Marie, we would say 10. Okay, but what might we write to say that there's not a point there? There's a few things you could say. Yeah.
Did you say no solution?
No solution. Undefined. I think yesterday we mentioned the phrase does not exist, like DNE for short. Okay? Any of those three would be fine. I think DNE would be the best one to fit in that little box, but you can write whatever you want to. All right, what about f of 5? If you were to plug in 5 on that dotted line, what would you get out? Good, Sarah? -5. All right, so 5, -5 looks good. Okay. So let's go ahead and try some of the G points. This time we're going to focus on the solid line. All right, little tricky, negative 3.2. So if we go over negative 1, negative 2, negative 3, and then a little bit more, okay, a little bit past negative 3, what does it kind of look like that we would be getting out? Maybe we should change this equal sign to an approximation sign, like little squiggles, because we're just guessing what this value is. We don't know what it is exactly. Can someone take a guess what we might be around? Good, Marie? 1.8, 1.9, 1.7, anything like that. We know definitely we're under 2. Okay, so you can't say quite 2. So anything under 2 I think would be fine. Okay, that's just an approximation. Go ahead and try G of negative 11 and G of 7. Remember, we're looking at the solid graph. What do you think for G of negative 11? Yeah, Rachel? Negative 2. Okay, so that actually is your endpoint, looks like. And what about G of 7? Go ahead, Ashlyn. Negative 1. Okay, so there's 7, and then negative 1. Looks good. We doing okay? All right, so we're going to step it up a bit. In the next row, we kind of have a different notation coming through. The first row that we did was only asking us about one function, okay, either the F graph or the G graph. But if you take a look at the next 3 we're going to tackle, notice how we see both graphs kind of showing up. It's asking us about F and G. Don't overthink these. Okay, can we take a guess as to what this notation is telling us to do? What do you think, Tori? There we go. So we're going to find where F of 3 is located, where G of 3 is located, and then we're going to add those two answers together. Okay, so algebra or mathematically, we're essentially finding F of 3 and adding G of 3. So let's go ahead and figure that out. On the F graph, if we were to plug in 3, remember the F graph's the dotted line, looks like we'd get negative 6. And if we were to plug in 3 on the G graph, which is the solid line, looks like we'd get positive 6. And we want to add those two results together. So negative 6 plus a positive 6. So our solution would be 0. Or our y value would be 0. Does that notation make sense? Don't overthink it. Okay? Let's go ahead and try the next one. We're going to find where F is negative 3, where G is negative 3, and we're going to subtract those two answers together. Maybe you guys can try the next one too. We're going to find where G is 9 and where F is 9, and then subtract those answers together. Let's see, any takers on the middle one, where we're dealing with negative 3? If you were to find the individual y values and then subtract them, what'd you get? You got 4. Okay, so did we get 6 for the first one? And then 2 for the second one, right? Subtract them together, we get 4. All right, and then what about the last one for the x value of 9? Let's see, g of 9. Did we get negative 3 for that one? Okay, and then f of 9 is also negative 3. They're in the same spot. Notice how they're both touching right there. So if we were to subtract those two answers together, notice how double negative would change to a plus. So negative 3 plus 3 would give us 0. Hanging in there? Okay, so we can simply add values together, subtract values together. Maybe we want to step it up even further and start throwing in some multiplication, maybe some division, some double multiplication. Okay, again, don't overthink these. So if we were to try to find f of negative 4, let's take a look at the dotted line for that one. Looks like we'd get out 6. And if we were to find g of negative 6 for that solid line, looks like we would get negative 2. Okay, but there's other things that this problem or notation is telling us to do. We're going to take 2 times this 6, because notice how we have that multiplier of 2 out front, and then we have to subtract that negative 2 value that we found for g of negative 6. So it looks like we'll have 12 plus 2, which would be 14. Okay, do you guys think you can try the other two based off the graph? Go ahead and give them a shot. Yeah, sure. How does 1/4 and 1 sound? Good, Tori?
How did you get the f of 17 value?
Oh, good question. Okay, so notice how f is the dotted graph, right? Okay, and 17 we don't really have on the graph, but this arrow is telling us that it's still going to continue that way, right? So we may have to be a little tricky, and perhaps if you continued to travel that way, maybe you could figure out what you would get, but it might be more beneficial for us to perhaps figure out the equation of that line. Okay, maybe we'll go ahead and write that down because I think we're going to use it for another question. If we're going to find the equation of a line, we got to figure out the slope and the y-intercept. Okay, where would it cross that y-axis? So based off that dotted line, can you pick 2 really good points and calculate the rise over run? Can we find that? Go ahead, Manny.
I have a separate question.
Sure.
For the g of negative 8 plus
Yeah.
f of 0,
Mm-hmm.
for the f of 0, it's not like completely, would it be completely on the 3 or would it be like slightly below?
It looks like it's right on the 3, right there. That blue dot I put on there. It might be a little hard to tell, but personally I think it's kind of going through, okay? I'll make sure when I give you this, like on a test or something, I'll make the graph bigger. I was just trying to save some space, okay? All right, can we find the slope of that line? Rise over run. Good, Rebecca? 1/2, okay. So we have a 1/2 x, and now we got to try to figure out what the y-intercept would be. Now the line, the way it is right now, does not cross the y-axis, but we got to think about if we were to extend it, where would it cross? So right now it's -1, 2, 3, 4, 5, 6, 7, okay. If we were to continue the slope backwards, go down 1, right 2, would be right there. Okay, but we're not quite on the y-axis yet. If we were to go down 1 and right 2 again, can we think about where we would cross? To me, it kind of looks like 7.5 or -7.5. Okay, not quite 8. So that would be our y-intercept. So to help you find f of 17, we would have to take half of 17 and then subtract 7.5 from that, and you'd get 1. Okay? We're doing okay? All right, so let's switch things up a bit. In our next row, we're taking a look at, this time we're going to find some x values. All the ones we were doing before were y values, so we're going to switch it up. We got to figure out when the y value is -6, what is the x value on the f graph. So when you go to your graph, go ahead and find the y value of -6. Okay, so that's somewhere down here. And you kind of got to visualize, where does that y value touch your f graph? In this case, your dotted graph. Can we notice how it touches the very tip or the very bottom right there? Okay, so if that's the point it touches, let's go ahead and trace up from that point to figure out the corresponding x value. So in this case, the x value would be 3. Okay, let's go ahead and try the next one. We're looking for a y value of -3. So if you want to kind of draw that line on your graph, you can. We're trying to figure out on the f graph again, okay, so the dotted graph, where does that dotted graph touch that y equals -3 line you drew? And this time it looks like we have 2 points. So we should have 2 x locations. Looks like we got 2 and, what's that other one, 9? Yep. All right, let's check out the next one. If we were to draw a horizontal line at 6, oh, this one's going to be good. Where does that horizontal line touch your dotted line? What do you think, Maddie? It is at 3. Okay, so there. Oh wait, that's the solid graph. Sorry. If this said g of 6, it would be 3. Okay, but since it says f, we're just looking at the dotted line. What do you think, Tori? Everything between -6 and -1. Can you include -6? Can you include -1? Yes, so we need those brackets. Everything between -6 and -1. So kind of like the domain and range we did yesterday, okay, you're giving that beginning point, ending point. because everything in between those is included. And if you can touch the beginning and ending point, we need those brackets. Is there another point? Would there be another point? Yeah, okay, so these are the points we can see, right? But we are told that this line is going to continue forever. Okay, so this one's a little tricky. You got to look at your entire graph. So if we were to go to the right a little bit more, if we had that ability, this value of 6 would eventually cross that dotted line. So there is one more value that we need to try to find. Okay, so we're going to use this equation we found to kind of help us answer that question. If we were to plug in 6 as the y value in that equation, we would have to add over the 7.5. So 6 plus 7.5, we would have 13.5. And then you can divide the 1/2 over or multiply by 2, whatever you guys are most comfortable with. So 13.5 times 2 would give us 27 as an x value. So you can definitely see that interval of -6 to -1, but we need to be aware that there would be another point if we were to extend that graph. Okay, be careful with arrows. Dots you don't have to worry about because those are just ending your graph. Arrows goes on forever, so you might have to check those. Okay, I want you guys to try the next 3. Okay, take a look at the G graph in these cases. Check out the -6, -3, and 4. This time the G graph is the solid line. Any takers on the first one? At which x values does the G graph have a y value of -6? Maybe we'll draw in that line to help us out. Where does that blue line cross or touch the solid graph? Anthony's shaking his head no. Is that what we're thinking? Never, right? So maybe we'll say none or no x values, no solution, something like that. What about if we did -3? Where do we touch or cross the solid graph? Go ahead, Maddie. 9, awesome. And what about 4? Where do we touch or cross the solid graph? Yeah. 0 and 4. How do we do? Good? Awesome. Okay, so let's take a look at 2 more questions about this graph. We're going to get into the computation work, okay, like some actual solving in these 2 cases. So for the first one, they're telling us, let's say we had some P equation. Okay, they're telling us that it's this quadratic. And we also know that we want to try to figure out for which values of x is the P equation equal to or the same as g of -3. Okay, so we're going to try to fill in this statement right here to help us answer this question. If we're solving for x, okay, for which values of x, That means we have to know a y value. If you're trying to figure out x, you need to know y. Vice versa, if you're trying to figure out a y, you need to know an x. Okay, you got to know something to help us out here. So let's go ahead and instead of having p of x on this left-hand side, let's go ahead and write the equation that it represents. Because after all, it says p of x equals that equation. Okay, we can do some substitution. They're the exact same thing. And then on the other side of the equal sign, let's go ahead and figure out what g of negative 3 is. So this is when we're going to have to take a look at the graph at the top, because at the top we have the graph of g. If you were to plug in negative 3 into the solid graph, which y value would you get out? Yeah, you'd get out 2. Okay, so when it's asking you or telling you that p of x equals g of negative 3, this is what it's actually meaning. Okay, when does this equation equal 2? So we're going to go through some algebraic steps to help us figure out these x solutions. What do you guys feel like doing from there to solve for x? What do you want to do, Maddie? Okay, we could do that. So that would give us 15 over here. What do you guys want to do next? Is there anything popping out at you? Anything else we can do to that equation? Yeah. Okay. So far, everything we've done is mathematically correct. Where do you want to go from there? What do you think, Tori?
Set of sides of x equal to 15.
Okay, so let me ask you this. We have this piece times this one, right? And we know the answer is 15, right? So that means that this piece could be 3, this one could be 5, maybe? Or vice versa? Isn't 3 times 5 15? Okay, maybe this piece is 15 and this piece is 1, or vice versa, right? Do you see how there are multiple options there? Okay, you guys are so on the right track. But what does this 15 have to be in order for you to break it up like Tori mentioned? Yeah, it has to be 0. Because if this is 0 over here, you know that either this piece is 0 or this one. And that's the only possibility. Does that make sense? Okay, so what we're going to do is we're going to go back up to the top. Okay, the steps you guys gave me are mathematically correct. Okay, they just might not be the correct ones to use in this instance. Okay, if you want to factor and eventually break up the factors, you need the equation equal to 0. So instead of moving over the 13, which you could have done, okay, let's maybe move over the 2. That way we get the 0 on that right-hand side. Okay, you guys had the right idea. It was just not working out in the process or method that we needed it to. Okay, so now that it's equal to 0, let's try to factor again. Now this is kind of that I am setup that we talked about earlier this year. Can we think about two numbers that multiply to negative 15 but add to 12? Yeah. Negative 3 and positive 5. All right, so now that the factors are set equal to 0, we know either the first one is 0 or the second. So solving individually, it looks like our x solutions would be 3 or negative 5. Okay, does that make sense? You guys had the right idea, but it just had to equal 0. Okay, let's go ahead and try the next one. Very similar question. They're telling us that the Q equation is this absolute value. And again, we're going to try to find those X solutions where the Q equation equals f of 5. So instead of having the Q equation written as Q, let's go ahead and write it as the absolute value they told us it is. And instead of that f of 5 notation, maybe we can figure out what that is based off the graph. If you were to plug in 5 on the dotted graph, what would you get out? Maybe. You would get out that on the solid graph. We want the dotted graph. Okay, the F graph. Can we find it? Go ahead, Brianna. -5. All right. So if we're going to try to find the X solution in this case, notice how we only have one X. So we want to try to get that one X all by itself. Can we start moving things to the other side? We did some of these yesterday, right? Maybe we can subtract over the 4. We can divide over the -3. Where do we go from there with our absolute values? I don't know if it was yesterday or the day before, but what do we do with absolute values? Can we dig deep? Go ahead, Rebecca. You're on the right track. Okay, either x minus 3 equals a positive 3 or x minus 3 equals that -3. You had the right idea of switching a sign, okay? So very similar to factoring, okay, we're going to break something up, but in this case, it doesn't have to equal 0, okay, because we're not really multiplying two things together. An absolute value changes anything negative into a positive, or anything that is positive stays a positive. So equaling 0 doesn't matter. We're just going to break apart that absolute value into a positive 3 or that -3 option. So solving individually looks like we get 6 or 0. We hanging in there? All right. We're going to stop there for today just because I want to make sure on the back we have enough time to thoroughly go through all of that without being interrupted by the bell. Okay? But for tonight, if you can find some time, let's see, you could probably do the first page of your homework assignment, okay, page 49. Looks very similar to what we did today, okay? Okay, we'll get into some of the back of the homework assignment tomorrow.